What's up, Algebra 2? Here we are with solving rational equations. So we just got done with multiplying and dividing, adding and subtracting, and now we're going to be solving. Okay, just from the last one with adding and subtracting, we were talking about getting a common denominator. And now that we are solving and have an equal sign, we're still thinking about what that common denominator would be, and we're going to multiply it to both sides of our equation, and that'll cancel out all of the denominators, and then we'll end up with just a regular algebra equation to solve. Makes it pretty easy. The reason we're doing it this way now is because we have an equal sign, and we can do things to both sides of an equation. Before, when we didn't have the equal sign, we just had a plus, and we're just trying to simplify. The only way to simplify them would be to get a common denominator so we can add them or subtract them together. But now that we have an equal sign, we can do things to both sides to make life easier. Okay, so we're looking at x plus 3 and then 6 and 18. So the first number that 6 and 18 both go into is 18. And then we have this quantity x plus 3. So we're going to multiply by 18 x plus 3 to both sides and everything on both sides. So we're taking 18x plus 3 to everything on both sides. Okay, with our first spot, the x plus 3's cancel out. And we have 4 times 18. The middle spot, we got a little bit of thinking here. I'm going to think about it as 18 divided by 6 is 3. 3 times 5 is 15. 15 times parentheses x plus 3. You could do 18 times 5, that's 90. Divided by 6 is 15. And then over here, the 18s cancel out, and we have 23 times x plus 3. Alright. We're going to distribute and simplify. 18 times 4 should be 72. We'll have 15x plus 45 equals 23x plus 69. Okay, we'll clean up the left-hand side here, and we'll have 15x plus 117. And now we just have an algebra equation. We got x's on both sides, we got numbers on both sides. I'd prefer to keep my x's positive, so I'm going to subtract the 15 over there. And then we'll move the 69 over here. That will give us 48 equals 8x. And if we divide by 8, we'll get x equals 6. Alright, so think about what the common denominator would be. Multiply that to both sides. And when you multiply it to both sides, you're multiplying it to everything on both sides. Okay, that should cancel out the denominators. Here it was 18 over 6, that's 3 times 15. In the other places it did just cancel out, straight up cancel them out. And that gives us everything just on the top row, and we can simplify and do our normal algebra. Alright, let's have you give this one a try. Go ahead and push pause and give that one a go. Alright, welcome back. Good try there. Let's see how you did. 2 and 10. The first number that 2 and 10 both go into is 10. And then we have the x plus 3 group. So very similar to the other problem. So we're going to go 10 times x plus 3 to all three spots. Our x plus 3's cancel here, and we'll just have 2 times 10 for 20. 10 divided by 2 is 5. 5 times 3 is 15. Or this one wouldn't have been too bad to do 3 times 10 divided by 2, 15, x plus 3's. And then these 10's will cancel out. We'll have 19 x plus 3's over there. Okay, now another way to go from here, instead of distributing, another way to go from here is, notice that these groups are both x plus 3's. We could subtract them. We could have done that up here too. This is like 19x and 15x. So you could just subtract the 15x and we'd have 4 times x plus 3. Because they're the exact same quantity, x plus 3 and x plus 3. So you can combine those like that because they are the exact same. So you could have done that. I'm going to guess you probably distributed. Okay, we'll put our numbers together, 15x plus 65. And we would have kept going and gotten 4x equals 8, x equals 2. Alright, time to level up to the medium problem. Okay, that one just had like one quantity and the rest were all numbers everywhere else. Now we're going to have a lot more quantities. Okay, it looks scary. It's really not. Okay, most of these problems are going to come from the textbook, whether like the reading, the actual problems in the textbook, or very similar to them. Because these are really tough to come up with on your own and have them like work out nice. So usually the big scary one in the middle is actually made up of the outside ones. Okay, so this x squared plus 8x plus 15 is probably going to factor, and it does, to x plus 5, x plus 3. If you need to do the magic x, thinking about what multiplies to 15 and adds to 8, go ahead and do it. Now you can double check the top and see maybe this factored out to like an x plus 5 or something and would cancel with the one right underneath of it. This is adding and subtracting stuff, so we cannot do like top-bottom canceling across different terms because this is not a multiplication, this is a subtraction and addition type problem. So it would need to be straight up and down within the same fraction to cancel out. This one does not. You're not going to find anything that factors or that multiplies to negative 10 and adds to negative 1. So I'm looking at my denominators. I got x plus 5. I got x plus 3. I got x plus 5 times x plus 3. So we're just going to use x plus 5 times x plus 3 to all 3 parts. And let's see what cancels out. Okay, our x plus 5s will cancel out over here, and we'll have 2x times x plus 3 minus x plus 5s cancel out, x plus 3's cancel out, and we're just going to have that group left. Now this is the tricky spot with this one. This is minus that whole fraction. All that's left from that fraction is the top, but that minus is still going to go to all of it. So I'm going to go minus parentheses, x squared minus x minus 10, so I don't forget to take that minus to all 3 things. And then on the right-hand side, the x plus 3's cancel out, and we'll have 3 times x plus 5. Now notice that these are not the same quantity, so I cannot just subtract this one over or subtract that one over. Okay, the example problems above, they were the exact same quantities, so we could try to combine them. Not the case this time, so we cannot combine those. Alright, we'll have 2x squared plus 6x minus x squared minus minus, so plus x minus minus plus 10 equals 3x plus 15. Okay, we do have x squareds involved, so we're probably going to be factoring to solve at the end, or if it's not factorable, then at least we could do quadratic formula. Either way, we're going to want everything on one side. Maybe clean this up first, huh? Let's clean this up first. 2x squared minus 1x squared is 1x squared. 6x plus 1x, we'll have plus 7x, and then a plus 10. Now we're ready to bring everything over together. We'll go minus 3x and minus 15. X squared plus 4x minus 5 equals 0. Now we're ready to try to factor. What multiplies to negative 5 and adds to positive 4? We'll go with a positive 5 and a negative 1. X plus 5. X minus 1. And then our answers will be what makes each spot equal 0. X equals negative 5 and x equals positive 1. Okay, and you're feeling really good about it because they're nice numbers, but guess what? That's not the right answer. Okay, it didn't happen in the first two problems, but it happened this time. Okay, this is not the right answer. One of these does not work. Why doesn't it work? And which one is it? Okay, we need to double check to make sure our denominators don't cancel out to 0. So when I put negative 5 in, we'll be dividing by 0 there and 0 there. And somehow it's going to be 3 divided by not 0. Okay, so negative 5 is not going to work. And we're going to make a little note because it makes the denominator, makes denom equals 0. X equals 1 should be fine. Okay, you could go through and double check to make sure everything's perfect. But the main error that we're going to be looking for is, does it make the denominator equal 0? That's the main thing we got to look out for. Alright, there is one more for you to try on the back. Let's flip it over. Should be pretty similar. Negative 12 over x plus 4 plus 13 over x plus 3 equals 18 over x squared plus 7x plus 12. Go ahead and think about that one. Give that one a go. Push pause and check back when you're done. Alright, let's see how you did. Hey, this one wasn't too bad. Didn't have any x squareds, it just had regular x's afterwards. And we got a nice 2. And 2 should be fine in our denominators, no errors there. Alright, that should do it for you guys. Good luck. Thanks for watching, and let me know if you have any questions.